Hello students, welcome back to Nanak Pathshala. There was a small glitch in the last video, so वो cut हो गया था. So we will continue. After that, we have studied the basic concepts, stress, strain, elongation. We have discussed this numerical. Now let's start the next numerical. Young's modulus of a material of a wire of length L and cross-sectional area A is Y. You all know we can denote Young's modulus through E as well as Y. So Young's modulus is, this is Young's modulus, nothing but, अरे इसको सही कर दो, चलिए सही कर देते हैं, कोई बात नहीं. Young's modulus. So क्वेश्चन बोल रहा है Young's modulus is given if the length of the wire is doubled and cross section area is halved, then Young's modulus. What effect you will observe if length of the wire is doubled? Initially L is 1 and afterward it is twice L1. Area is halved, A1, and afterwards is A1 by 2. So what change will you observe when you double twice or double the length and half the cross-section area? So you all know Young's modulus is nothing but the inherent, it is the inherent property or internal property of material. It is the internal property of material. No change will be observed if you take any cross-section, any length, any area or any cross-section. You will take, the Young's modulus of the material will not change because it is the inherent property of the material. Okay? चलिए आगे बढ़ते हैं. When a wire is subjected to a stress of, okay, this is good, stress is given as 8 multiplied by 10 to the power 8 Newton per millimeter square, and its length is increases by 0.40%. This is very important concept. Okay, what do you know? What do you observe from increases? It is nothing but change in length. Okay, the length is increasing and it is nothing but change in length. So convert 0.40 into, it is given in percent, convert it into a numerical value. So you all know percentage से convert करना, divide by 100. So the value increase in length is equal to 0.004. You all know we have to calculate Young's modulus. Okay, no problem. Young's modulus is, oh, just a second. Increases, yes. Increases. This is the strain. This is the strain in the material. Length is increasing by this percentage. So this is the change in length upon original length. Increase in the length. Okay, change in length. The length is increasing. So this is the strain. This value is the strain value. हाँ, इतनी छोटी वैल्यू होती भी नहीं है, स्ट्रेन की होती है. चलिए, now you all know Young's modulus is nothing but stress upon strain. Put all the values. 8 multiplied by 10 to the power 8 divided by 0.004. So you will solve this in numerical and get 2 multiplied by 10 to the power 11 Newton per meter square. ये तो इजी है, इसमें कैलकुलेटर भी नहीं लगेगा. चलिए आगे बढ़ते हैं अगले क्वेश्चन से. दिस इज समथिंग गुड. ये आपने सबने क्लास में किया हुआ है, सो इसमें ज़्यादा दिक्कत नहीं आएगी. अभी तक तो बेसिक क्वेश्चन चल रहे थे. दिस इज क्लास के क्वेश्चन. चलिए, अ रॉड ऑफ, क्वेश्चंस होंगे आपके पास, समझा देता हूँ बस. अ रॉड ऑफ 150 सेंटीमीटर लेंथ इज गिवन इन सेंटीमीटर, diameter is given in 2 centimeter, subjected to axial pull off. This is the value of force, 20 kilonewton. If modulus of the elasticity, Young's modulus is also given 2 multiplied by 10 to the power 5 Newton per millimeter square. Determine stress, strain, elongation. First step, convert all the units in SI form or millimeter. Why millimeter? Because modulus of elasticity is given in millimeter. Okay, convert kilonewton into Newton and modulus 150 centimeter and 2 centimeter in millimeter. Let's see, 20 millimeter area pi by 4 d square, or you can simply write pi r square. The value will be same. Okay, you have to write the value which is observed in calculator. Load to 20,000 Newton and Young's modulus of elasticity also given. You all know stress is nothing but force upon area. The value of force in Newton is 20,000, area is 100 pi. So 63.6 Newton per millimeter square is coming. Now, first equation is stress is force upon area. Second equation, Young's modulus of elasticity is nothing but stress divided by strain. You can denote strain by epsilon or E also. So the value of E will be stress upon Young's modulus, 63.6 upon 2 into 10 to the power 5. This value of strain you will observe. Elongation. Strain is del L upon L. Del L is strain multiplied by length. This is the value of strain multiplied with the original length, 150 centimeter. So you will get this value in centimeter. You can also calculate this value in millimeter. Keep all the values in millimeter, okay? That will be easy to go. Next numerical, very important numerical from your exam point of view. A safe stress for a hollow steel column which carries an axial load of 2.1 into 10 to the power 3 kilonewton is 125 mega Newton per meter square. This is the value of stress and this is the value of force. If the external dia of the column is 30 centimeter, determine the internal diameter. Easy. चलिए, stress converted into Newton per meter square. Questions easy हैं, सिर्फ समझा रहा हूँ. Units, you have to give proper attention on units. Otherwise, numerical value will be different for everyone. Load converted from kilonewton to Newton. Diameter from centimeter to meter. Internal diameter we have to calculate. So area of a hollow section is pi by 4 capital D square minus D square. You can also write it as pi r square minus r square. This is also the area in radius form. Okay, we have put the value of D, capital D, as 0.30 and small d as D. So stress, the value of stress is, we all know stress is equal to force upon. Value of stress is given, value of force is given, value of area is given. Given नहीं अपन ने calculate कर लिया. So put these all values in the calculator, or you can divide 125 into 10 to the power 6 by 2.1 into 10 to the power 6 and equate it by pi by 4 0.30 square minus d square. So इतना तामझाम करने की ज़रूरत नहीं है, कर लो तो अच्छा है, नहीं तो this is the final value 26.16 centimeter. चलिए, only in this question area of a hollow section is important. This area is important. This area is of important. Find the minimum diameter of the steel wire which is used to raise the load of 4000 Newton if the stress in the rod does not exceed 95 mega Newton per meter square. Nothing tough. For value of force is given, very good. Value of stress is given, superb. Diameter we have to calculate. We know stress is nothing but load upon area. Putting the value of stress as 95, putting the value of load as 4000. You have to write, okay, you have to write 4000 Newton and this convert this into Newton, mega Newton, by writing 95 multiplied by 10 to the power 6. ये यहाँ पे देखो, ये किया था ना, मेगा न्यूटन से न्यूटन. So 95 into 10 to the power 6. 95 into 10 to the power 6. 4000 divided by pi by 4 d square. So all the values are in Newton meter square. So अगर आपको करना है तो मीटर स्क्वायर से मिलीमीटर पे भी जा सकते हैं. This value is coming out to be, d square value is coming out to be 53.61 and final d value is 7.32. Direct put this equation in the calculator and you will get the value of D, capital D. Okay, diameter. Very important question from exam point of view. Assignment में भी दिया था आपको. So, a tensile load was conducted on a mild steel bar. Following data is observed. वीडियो पॉज करके सारा डेटा देख सकते हैं. Determine Young's modulus, stress, percentage elongation and percentage decrease. चलिए जीरो से शुरू करते हैं. Young's modulus. For calculating Young's modulus, what is required? We required stress and strain. So using the given information, first find out stress and strain. For stress, we all know area of the area is required. So area is pi by 4 d square. Diameter I think is given in the first step. Very good. So area is pi by 4 d square. Put करोगे कुछ वैल्यू आ जाएगी कैलकुलेटर पे. स्ट्रेस फोर्स दिया है. यस सर, फोर्स इज ऑल्सो गिवन. कहाँ है फोर्स? फोर्स कहाँ है? मैक्सिमम लोड इज गिवन. लोड एट इलास्टिक लिमिट. लोड विद इन इलास्टिक लिमिट इज गिवन. ओके 250. अच्छा ये गलत हो गया क्वेश्चन. जस्ट अ सेकेंड. हाँ जी. स्ट्रेस एट इलास्टिक लिमिट एंड okay, just a second. What is the question? Young's modulus, determine the Young's modulus, stress, कुछ तो गलत है क्वेश्चन में. लोड ये 150 कहाँ से आया? लोड इज ये तो 250 है. ओके जस्ट अ सेकेंड, आई विल चेक द क्वेश्चन. एक मिनट रुकना बच्चों. The numerical value is misprinted. Just a second, I will check the question. Okay. Value of the load is also given. Value of load is also given in the question. First, you are assuming that why you have taken it the correct है. 150 is correct. हाँ important है ना, ये तो भूल ही गया था मैं. चलिए अगर आपने ये क्वेश्चन ढंग से देखा होगा. ओके लोड एट इलास्टिक लिमिट इज 250 न्यूटन. एक्सटेंशन at load of 150 kilonewton is 0.21. So with respect to the elongation 0.21 mm, load is given 150 kilonewton. Why? This is the load within elastic limit. Okay. At elastic limit, load is 250 kilonewton. Within elastic limit, in which the extension is 0.2 mm, the load is 150 kilonewton. That's why we are putting the value as 150 kilonewton. Very important point. So stress is load upon area. Area we have calculated. Load value is 150. Why 150? Because it is within elastic limit. Okay. So value आ जाएगी something. Strain, increase in length upon original length. Increase in length we have calculated with respect to this load. अगर ऐसा लगे ध्यान से आप इतना समझ लीजिए, ये यंग्स मॉडुलस जो आप निकाल रहे हो ये 150 किलो न्यूटन के लिए निकाल रहे हो. ओके दैट्स व्हाई इंक्रीज इन लेंथ यू हैव पुट एज 0.21 एंड ओरिजिनल लेंथ इज 20 सेंटीमीटर. ये दिया हुआ 20 सेंटीमीटर. सो इंक्रीज इन लेंथ इज 0.21 mm, ओरिजिनल लेंथ इन 20 सेंटीमीटर और 200 millimeter. Divided and you will get this strain. Young's modulus is nothing but stress upon strain. This is the value of stress, this is the value of strain. Divided, you will get the value of Young's modulus. Keep it in readable form. Okay, keep it in readable form. Or you can also convert it into mega Newton or giga Newton. It's your wish. Stress at elastic limit. Second step लिखा हुआ है कहाँ? ये देखो at elastic limit. So stress is load upon area. Load is given at elastic limit 250. ये देखो 250 Newton. 250 upon area will be same. So the stress will be 353.68 mega Newton per meter square. Percentage elongation. So you all know what is elongation? Change in length upon original length. So total increase in length is also given in the question. extension, total extension 60 mm. Total increase in length upon original length is, or gauge length is 200 mm. Multiply it by 100. If you have to calculate any value in percentage, just multiply it by 100. You will get the value as 30%. Percentage decrease in the area. Area, you all know what is percentage decrease. This is the percentage elongation. Total increases, change in length plus original length or minus. So, percentage decrease is also original length minus area at failure upon total area. Change original area minus change in area divided by original area. Okay. Final value minus initial value upon final value. You will get the value of percentage decrease. So, original area is, the diameter is 3 mm, so 5 by 4 d square. The value of area at failure. What is the dia at failure? ये देखो, diameter of the rod at failure 2.25. Originally 3 centimeter है, 2.25 पे आके fail हो रही है rod. So original value minus at the failure upon original value. You will calculate this. You will get 43% approximately. On calculator, it will approximately 43%. Next important question. ये वाला थोड़ा सा लेंदी हो गया, देख लेना आराम से एक बार और. A stepped bar as shown in the figure is subjected to an axial applied compressive load of 35 kN. Find the maximum and minimum stress produced. First, load is given 35, maximum value and minimum value. A small concept is used in this question. Diameter of the first upper part is 20 mm. Second part is 30 mm. Okay, centimeter में दिया है, mm में कर लिया. So area of upper part is pi by 4 d square, 100 mm pi. Area of lower part और second part is 225 pi. Pi की value put कर देना, value मिल जाएगी. So maximum load and minimum load. A small concept is used in this question. When you will calculate maximum load, stress will be maximum when, ये देखो, stress होता है force upon. If area is minimum, stress will be maximum. Stress is inversely proportional to area. If area is minimum, stress will be maximum. तो area minimum कहाँ है? Upper part पे, lower part पे? Upper part पे. So the maximum stress is at upper part, where area is less as compared to the lower part. So maximum stress load upon A1. This is the maximum stress. Minimum stress load upon A2. Why? If stress is to be minimum, area will have to be maximum. So the body, lower part of the body has maximum area. Stress will be automatically minimum. So you will get some value. Okay, concept important है. न्यूमेरिकल वैल्यू तो आप ले आओगे कैलकुलेटर पे. चलिए, ये एक ऐसी चीज़ है जो आपने अभी तक नहीं पढ़ी है, तो थोड़ा आराम से पढ़ना है इसको. ठीक है, आई विल प्रेफर थोड़ा आराम से देखना, कोई जल्दबाजी मत करना इसमें. ठीक है, चलिए शुरू करते हैं. सो अ मेंबर ABCD is subjected to point load P1, P2, P3 and P4 as shown in the figure. Calculate the force P2 necessary for equilibrium. Condition is given, P2 is at equilibrium. Hope you all know what is the condition of equilibrium. The summation of all the forces at this point is 0. So P1 value is given, P2 value we have to calculate, P3 is given and P4 is given. Total elongation also we have to calculate. Assuming modulus of elasticity, no problem. So as you all can see, the area, consider this section 1, section 2 and section 3. Area of section 1 is 625 millimeter square. You don't know the area is circular, rectangular, square, nothing. So directly area is given. Area of second section is 2500 millimeter square. Area of third section is 1250 millimeter square. Length of first section is 120 centimeter, second section 60, third section 90. So you all know, we can see that these are all horizontal forces. So you can directly apply the equation of equilibrium in x direction. What is the value? Consider one side as positive, other is negative. So what we can say P1 plus P3 is equal to P2 plus P4. Left hand side is equal to right hand side. Put the value of P1, P3, P4, you will get the value of P2. ऐसे ही किया होगा ये. हाँ जी, ये देखिए P1, P3 is equal to P2, P4. ये कर रहे थे अपन. हाँ जी. Putting all the values, you will get P2 as 365. Now area given, ये already बता चुका हूँ. Length is given. Second area, second length, third area, third length, and Young's modulus is also given. Now you have to draw the free body diagram of individual section. Section 1, section 2 and section 3. So out of 365, if this section is in equilibrium first, if P1 is 45, P2 must be in 45. P2 must to be in 45. So ये 45, ये 45. Okay. अब 365 में से 45 माइनस कर दो 320 आ जाएगा. So by default ये 320 है 320 both P2 and P3 दिया था क्या 450. Okay, no problem. P2 and P3 is 320 because this section is in equilibrium. So out of, as given in the question, P3 is 450. P3 is 450. Subtract 320 from this, you will get approx 130. So third section, this is section 1, section 2 and section 3. Third section, 130 kilonewton is applied here. So by default 130 will be applied here. And P4, you can see P4, the value of P4 is 130 kilonewton. All the three free body diagram is drawn. Calculate individual increase in the length. You all have seen in the last video that change in length is calculated by PL upon. So change in individual section is calculated. Change in length 1, change in length 2, decrease in some cases increase and in some cases decrease will be observed. So you can write negative value also. Okay, you can write negative sign and write change. You don't have to write increase and decrease, just change is sufficient. Okay, so change in length 3 is written as by this formula. Put all the values, solve it in calculator, you will get 3 values of del 1, del 2 and del 3. Total change, for total change add all 3 values plus minus plus because second value is coming negative. So a total of 0.49 mm extension. Positive sign means extension or increase in length. Negative sign means decrease in length. Okay. So total and extension of 0.49 mm is observed in the question. Very important question. You must try this question twice. Okay. चलिए. Oh, finally हो गया. चलिए. Thank you everyone. Hope you all like the video. Questions में अगर कोई भी डाउट हो, you can comment it in comment section. और ऐसे ही वीडियोस के लिए आगे मिलते रहेंगे. ओके, चलिए.